Hi, so just a quick little video to demonstrate the capabilities of the Baumer OXM blue laser sensor, particularly on this video for transparent targets. So just to show you here, we've got our nice blue laser profile line here of the sensor here with the inputs and outputs and connection LEDs showing here. It works from 60 to 85 mil away from the target, giving us a width of line from 20 to 28 mil in that working distance. So like I said, very good for transparent targets and very shiny and targets that give lots of specular reflection, because we're using a blue laser rather than a very penetrative red laser.
So first things first, let's get connected to the web server software. So just type in the IP address of the software and it will then connect. Okay, so let's just get in and start parameterizing the sensor here. So into start. To make it easier to visualize what's going on, we'll just stick to the profile only. And the OXM 200 blue laser is very good at detecting transparent targets, or seeing the profile of transparent targets far better than the red laser because it's too penetrative. So what's really important and what's good to show you is what the capability of the sensor is. So you can see I've mocked up a cellophane wrap on a semi-transparent target under the sensor here.
So with the target in place, you may need to change the exposure time or change the strength of the laser to be able to see your target as well as you'd like. But you can see on the cellophane wrap, I get a very good signal straight away. If I click optimize, no change here when I've got the laser line at strength 1. Okay, so I can now go into measurement tasks as you would, and I can do various tasks with that, and I can look at the height, say the average height or the min max or the delta, all that type of thing, and I can play around with that target there. So you can see on a clear cellophane wrap on a semi-transparent target here, if I start to play around with the surface there, you can see I'm taking measurements from it and able to do some quite intricate measurements, even with something as tricky as that. And I can go against a profile where there's some wrinkles and things like that. So you can see introducing some wrinkles there to the surface, and I can measure those very well. So quite tricky for a red laser to do because it would pretty much see straight through it even on low strength. So the blue laser gives us a nice non-penetrative beam, giving us good reflections off the top surface, allowing us to do measurements like so. Of course, there's other tools and things you can use, but just to show you the power of the blue laser and what would be suitable targets or targets that you may find tricky already to deal with. So we can do things like area measurements underneath that, and you can see as I manipulate that, I can change the criteria of the profile underneath the sensor. Okay, let's get rid of those. Even we can do things like clear liquids. Not really advised, but if you have such an application, you can see let me place that under the beam itself. So this needs a bit more of a change in the data acquisition. So what's the best light to get out of that? So we've had to increase the exposure time to be able to see nicely the profile of the water in the vessel here. So it's clear vessel, obviously water in there. If I get to the edge there, you can see the edge of the glass and also where the water starts. If I move that across in here, just so it's over the liquid itself, and you can see as I move it, it creates a sort of wave effect. If I go to measurements now and add height measurements, for example, I can see the level of the water, the average height of my datum point, where is 0 on there, and I can then say blow on the water to create a ripple, and you'll see the effect of that. And you can see that moving about. I could even slosh it like so, and you can see the water wave moving on there, and we're getting changing measurements there on the right hand side of the average height of the liquid. But really, the profile sensor or the height measurement sensor at multiple points is able to do tricky transparent plastic targets and things like that. So things like pipettes or vials or things like that. So if I just move the sensor into its measuring range, here we go. So there, let's have a look at it there. Let's tighten that bracket up. So you can see I've got a pipette in there, transparent pipette in there. And I can get it in the center here. Let's just optimize the signal here and clear up some of the noise. So you see some of the noise went missing. We'll go back into the measurement tools that we have available to us. Let's get rid of that height tool. Say we're dealing with a circle now, a circular target. What can we do here? So we can measure the diameter, where is the center, all these types of things on a transparent target there. And you can see I can rotate that round over the completely transparent bits, or even bits with some writing on. You can see what it does there when it's got some writing on there, so we can pick up on the writing as well. So that type of thing. If I move that in and out, you can see that's doing that very consistently, very well. And then also targets like plastic spoons, semi-transparent targets, things like that, measuring profiles, whatever. Of course, we're not dealing with a circle anymore, so let's remove that circle tool. Add, say, something like a width tool, for example, and you can see I'm picking up on the width of that spoon there. And also I could have multiple tools. Maybe I want to do the height of it as well, the average height or the max and min heights, and you can see all those measurements being output there, and the width there. I can move that around in the field of view there to get a consistent value. And if I push the end of the spoon through so it gets narrower, you can see how the value changes and the height changes.
Okay, so now that we've got this small container in front of the sensor itself, you can see I can't just quite pick up on the edge of the cup there itself. So worth again changing targets, changing the strength of the laser, maybe, to try and pick up on that bit there. Now you can see a little clearer. So we can do, again, height measurements, width measurements, all sorts of things, tracking the target. So let me just get rid of these tools. Keep the height tool, and you can see the average height here, the max and the min. Here, if I change the field of view, you can see the average height will change and things like that. You can do, of course, if I changed the angle, say, of the target, I can do that and look at the angle here of, say, this edge here. And if I tilt, you can see what angle that comes up as now. So you can see the angle here. Of course, you can see the lip of the vessel on either side there. So yeah, just an example of what you can do with the OXM blue laser. Very good with transparent targets. Also very good with very shiny and targets that can give a lot of specular reflection. But I just wanted to throw some targets underneath that will show you that it can be used on packaging materials, small semi-transparent and fully transparent targets for height and width measurements, whatever profile criteria you wish to measure and output.